afternoon, everyone, and this is Naveena from the Department of Cybersecurity in the Institute of Aeronautical and Engineering. And today, in my video, I want to discuss regarding the introduction to data link layer protocols. Under this, the types of the protocols and the two types of the protocols like the connection-oriented protocol and the connectionless-oriented protocols, and the HDLC frames, and coming to that, finally, the addressing fields of data link layers. So coming to that, and my first slide is nothing but coming to this one, the data link layer protocols. And traditionally, there are four type of protocols have been identified or defined for the data link layers to deal about the error detection and the flow of control under the framing of the packets from one sender to the another receiver. So under this, the first type of protocol is the simple one. Second one is the stop and wait. Third one is the go back in and selective repeat. And although the first two protocols still they are in the using mode at the data link layer level, the last two might have been disappeared. And under this one, there are two types of protocols we need to identify. The first one is the connectionless protocol. Second one is the connection-oriented protocol. Like under the DLL, the two types of protocols we have to identify. The first one is the connectionless. Second one is the connection-oriented. So the first one is the connectionless and second one is the connection-oriented protocol. So in this, in a connectionless protocol, the frames are sent from one node to the next node without having any relationship between the frames. Suppose any frames or any packets they need to transmit from one sender to the receiver, definitely they might be having or they will have a need to set a certain path. Like in this connectionless protocol, the frames are sent from one node to the next node without having any relationship between the frame. Means, suppose if you are taking the example of the transmission of packets from one sender to the receiver under the data link layer. So under this, the transmission of the packets, they should be in this mode only. So in this type of transmission, we should not identify or recognize any type of relationship or any physical path. This is what we can call it as a physical path. Physical path between the two sender and the receiver host, or the sender and the receiver host. That is nothing but the one of the example for the connectionless protocol by means of a pictorial. So in a connectionless protocol, the frames are sent from one sender to the receiver by means of from one node to the next node without having any physical path. We did not identify any physical path or any communication between the sending of the two frames from one sender to the receiver or from one source to the destination host. This is the first point. And second one is each frame here, it should be an independent, like that frame 1, frame 2, frame 3 and frame 4. Each frames should be done or should be behaving like in an independent mode. And second one is note that the term connectionless here does not mean that there is no physical connection or any transmission media between the two nodes. It means that there is no connection between the frames. That I have already explained. Connectionless means we should not identify any type of transmission media or any physical path, any physical communication between the sender and the receiver or one source and the destination host. So here we need to identify, we did not find any physical path between the two type of nodes. It means that there is no connection required between the sending of the frames from one node to the another node. And finally, and I want to discuss, the frames are not in a number and there is no sense of ordering. Mostly, the data link layer protocols are meant for the LANs or connectionless protocols. These data link layers, and the example for the data link layers are nothing but the LANs, local area networks. We have to see the transmission of sending the frames from one source to the receiver by means of a LAN connection under the connectionless protocol of data link layer. So after this, we need to discuss about the connection oriented protocol. In a connection oriented protocol, it is like the opposite of connectionless protocol. Here, what we have identified, there is no required of physical path or physical communication or transmission medium who might be seen under the sending of the frames from one sender to the another receiver. But here, who might be required a logical connection or a one physical path, a certain path need be required for sending the frames from one sender to the receiver or from one source node to the destination node. In a connection-oriented protocol, mainly a logical connection should first be established between the two types of nodes. That means this is the one physical path or logical connection we should be established from one node to the another node. It might be required the one physical path or logical connection between the one sender node and the another receiver node. And after that one, after all frames, they are somehow related to each other. That means whether the logical connection is terminated or in the phase of a tear down phase. In this type of communication, we need to recognize the frames are in the mode of a numbered and sent in the order way. We need to recognize here the frames we should be transmitted from one node to the another node. They should be in a order way and they should have hold some numbering. That frame 1 like frame 2, frame 3 and frame 4, 5, 6. And they should be in the order. They need to send or transmit from one source to the receiver or from one sender to the receiver in a order mode only. If they were not received in a order and whether they were in a some disorder, the receiver needs to wait until all frames belonging to the same set, whether they have received and then delivered them in order to the network layer. So this is the main concept which should be required. We need to discuss under the connection oriented protocol. And connection oriented protocol we have to identify under the wide LANs. Wide LANs, this is the example for the connection oriented protocols. But we have to see them in some P2P protocols like point-to-point protocols also we might be seeing in some part of point-to-point protocols and some wireless LANs and some WANs also. Mainly, the main difference between the connection-oriented and connectionless protocol is the connection-oriented, a physical path or a logical connection is required to transmit the data frames or data bits from one sender to the another receiver. And second point, the frames should be in the mode of a number. They need to send it from one sender to the receiver in a order way. And at the receiver side, it needs to wait until and unless it will receive all the frames from the source node or from the side of sender. This is the connection oriented protocol. Whereas in the connectionless protocol, we need to require does not require any physical path or any logical connection between one sender to the another receiver. And here the frames may be numbered or may not be numbered and they will be having no sense of ordering. That is the main difference between the connectionless and connection oriented protocol. And coming to that, the first one, the last one is nothing but the stop and wait protocol. Our second protocol is called the stop and wait protocol, which is uses, this is also one of the error detecting protocol, which is uses for both flow and error control. And in this type of protocol, the sender sends one frame at a time and waits for an acknowledgement before sending the next one. Suppose this is the sender wants one frame to the receiver and waits for the acknowledgement before sending the next frame. A sender can able to send one frame to the receiver and waits for the acknowledgement of that concerned frame before sending the another frame. And here, to detect the corrupted frames, we need to add a CRC to each data frame. When a frame arrives at the receiver side, it is checked. If its CRC is incorrect, the frame is corrupted and silently discarded. Meanwhile, sending all the frames, if any bit or any frame will be corrupted or discarded, it will be silently discarded and it will be transmitted to the sender, and again it will have a need to check it once again and then retransmit it by means of according to the schedule given by the frames. That is the main concept included under the stop and wait protocol. And coming to the next point, and the silence of the receiver is a signal for the sender that a frame was either corrupted or at last. So whenever, every time the sender sends a frame, it starts a timer. Here the one of the best advantages while you are working with stop and wait protocol is nothing but the timer it needs to set. If you set the timer, if an acknowledgement arrives before the time expires, the timer is stopped and the sender sends the next frame if it has only one to send. Or if the timer expires, the sender resends the previous frame, that means the first frame, assuming that the frame was either lost or corrupted. This is the main concept which should be included under the concept of stop and wait protocol. The first one is when a frame arrives at the receiver side, it is having some error detecting check code, what we can call it as a CRC, cyclic redundancy code, which is used to include to checksum the bits whenever any one bit it will be corrupted or discarded while transmitting from one sender to the another receiver. And second advantages of using stop and wait protocol is nothing but it will set the timer. If an acknowledgement arrives, that means if one frame or a packet can able to transmit from one source to the another destination or from one sender to the another receiver, it arrives before the timer expires, means the timer is stopped. If the timer expires, the sender resends the previous frame, again assuming that the frame was either lost or it will be corrupted. Before it will be coming means before the packet it will be coming, when the time it will be setting, before that packet can reach means the timer already stopped and the sender sends the next frame. Or else if it is not stopped until unless if the one frame is coming or transmitting from the sender side, the sender resends the previous frame assuming that the frame was either lost or corrupted in the middle of the transmission. That is the main concept of stop and wait protocol. And coming to that, the next protocol is, the fourth protocol is nothing but the simple protocol. And the stop and wait protocol, simple protocol, still they are not in a using mode. The first two protocols, what we can already discuss, the connectionless oriented and connection oriented, they are still in a using mode. Simple protocol. Our first protocol is a simple protocol with neither flow or an OR, error control or heavy control technique. We assume that the receiver can immediately handle any frame it receives. It needs to receive how many frames a sender can able to send, whether by means in an order way, along with the number oriented, the receiver can able to receive that much of nodes in that mode only. In other words, the receiver can never be overwhelmed with incoming frames. Overwhelmed means it is overloaded. So in other words, the receiver can never ever be overloaded with any incoming frames. So the data link layer at the sender gets a packet from its network layer, makes a frame out of it and sends the frame. The data link layer or DLL at the receiver side receives a frame from the link, extracts that packet from the frame and delivers that packet to its network layer. This is the main concept which should be included under the simple protocol of data link layer protocols. So coming to that, and this is one of the most and important protocol which is designed for the unidirectional communication, what we can call it as a piggy bagging. Here the two protocols we discussed in this section are designed for unidirectional communication, in which data is flowing only in one direction, although the acknowledgement may travel in another direction. That means Here if you can take the example here, and the data can able to transmit between the two nodes, one source node or one sender node and the another receiver node, and in which the data is flowing in only one direction, although the acknowledgement may travel in another direction. Data can able to travel, that means sending the frames, and they may be travel in one direction, and receiving frames they will acknowledge in another direction to the concerned sender. That is the first point. And here the second point is nothing but the protocols have been designed in the past to allow data to flow in both the direction, not only to mend or to transmit the data or frames in one direction, they should be in both the bidirectional. That means sending the frames or sending the packets in one direction means acknowledgements those type of packets in some other direction. That means sending the packets from the sender side and acknowledge those type of packets from the receiver side. And however, to make the communication more efficient, the data in one direction is piggybacked with the acknowledgement in the another direction. And in other words, if you can define the two nodes, when node A is sending to node B, node A also acknowledges the data received from node B. Because the piggybacking makes communication at the data link layer, it is more complicated. It is not a common practice. So coming to this, the data link layer HDLC. And HDLC means, if you can define the HDLC or high level data link layer protocol. So under the data link layer protocols, the HDLC is a part of a protocols of data link layers which should be defined or which should be abbreviated in the form of a high level data link layer control protocol. High level data link control protocol. It is nothing but a bit oriented protocol for communication over the point to point and multi-point links in between one point to another point or from one point to the many points. One to many and one to one. So this is nothing but the P2B and this is nothing but the multi-point. So here it implements the type of the protocol as already we have discussed, the stop and wait protocol. HDLC, that means already we have abbreviated high level data link control, is a group of communication protocols of the data link layer for transmitting the data between the network points or nodes. And the next one is, since it is also considering as a data link layer, part of data link layer, the data is organized in the form of a frames. The data is organized in the form of a frames, some A1, A2, A3, A4. So a frame is transmitted via the network to the destination that verifies its successful arrival. Whenever a frame wants to transmit it from one node, it reaches and it accepts to its destination in a successful mode or in a successful arrival mode. As I have already told that it is a bit oriented protocol which is applicable for both point-to-point protocol as well as the multi-point protocol. And again I need to inform and I want to define one word. High level data link control is a group of communication protocols which should be included under the data link layer for transmitting the data between the network points or nodes. So coming to that, under this we have to identify the two types of transfer modes. The first one is the normal response mode. Second one is the asynchronous balanced mode, ABM. The first one is the normal response mode. Second one is the asynchronous balance mode. We have to identify the two types of modes here. The first one is the transfer modes. HDLC supports the two type of transfer modes. The first one is the normal transfer mode or response mode. Second one is the asynchronous balanced mode. The first part, normal response mode or NRM. Here the two type of stations are there. A primary station that sends commands and secondary station which can respond according to the received commands. It is used for both P2P as well as and point to multi-point protocols. Point to multi-point protocols. So let us see the example it should be given by means of a HDLC NRM. So the first one is the normal response mode. According to our given figure, we should be shown under the below of HDLC NRM. So here we have to identify the primary station, and here the second node is nothing but the secondary station. We have to identify under the given figure the commands which should be transmitted by means of a one logical connection in this mode only. So the response by means of a secondary station will be acknowledged or need to reach to the primary station in the secondary way. This is normal response mode. So coming to that, the point-to-point communication or under the multiple point communication, and one primary station we have to identify here. The number of commands they would be transmitted by means of a one physical path or by means of a one logical connection. They need to transmit to the secondary station of 1, secondary station of 2. So again, the station 2 response plus the station 1 response, they need to transmit to the primary station 1. Why? Because the commands from the primary station received to the two types of station 1 and the station 2, like that only the two type of responses they need to give it and transmits through this physical connection to the station, primary station 1. So that is one of the example of HDLC NRM. So coming to that, the second one of HDLC transfer modes is nothing but the asynchronous balanced mode, ABM. Here the configuration is balanced, that each station consisting of the two types of commands, two types of responses we need to identify here. The first one is station 1 and second one is the station 2. Here each station can both send the commands and respond the commands in a parallel way. Here if you can identify, station 1 can able to send the command and response in one side, and station 2 receives that command and response and resends it, that command and response to that station 1. The station 1 sends and it will reach us to the station 2. It is used for only point-to-point communication. The same type of command and response will parallelly acknowledged or shared from one station to the another station under the asynchronous balanced mode. So coming to this, to provide the flexibility necessary to support all the options possible in the modes and configurations just described under the HDLC layer protocols or frames, it defines the three types of frames. The first one is the information frames, second one is the supervisory frames, third one is the unnumbered U frames. First one is the I frames, second one is the S frames, third one is the U frames. So coming to that, each type of frame serves as an envelope for the transmission of a particular or a different type of messages from one sender to the another receiver. And iframes are used especially in the data link layers for data and control information relating to the user data like piggybagging. And coming to that, the second frames are nothing but the S frames are used only to transport control information. So coming to that, the third frame, what we can call as U frames, are reserved for system management. And information carried by U frames is intended for managing the link by itself. So coming to this one, each frame in HDLC may contain up to 6 level of fields. So coming to this, the beginning flag field, an address field, a control field, an information field, a frame check sequence FCS field, and an ending flag field. In multiple frame transmissions, the ending flag of one frame can serve as a beginning flag of the another field. So the first one is nothing but what we can call it as a flag field. This field contains synchronization pattern like 0, 1, 1, 1, 1, 1, 1, 1, 0. which identified both the beginning and ending of the frame. If you can divide this frame format, means it will be like in the mode. If you can divide or scrutinized or sliced the frame, means it will be 0, 1, 1, 1 and 1, 1, 1, 1, 0. So we need to divide or slice it the one frame in this mode only. Here we need to identify the two types of frames. The first one is the beginning frame and second one is the ending frame. Ending frame, and consisting of both the head and trailer. A frame consisting of head and trailer also to check some the bits, whether for the sake of the transmission, while transmitting the bits from one sender to the another receiver, if any bits, it will be corrupted or discarded. So for that sake only one header and trailer will be needed for every frame before starting or sending the frames transmitted from one sender to the another receiver. So coming to this next address field is nothing but this field contains the address of the secondary station. If primary station created the frame, it contains to address. If a secondary station will create the frame and it contains to address and it contains from address, this address field can be 1 byte or several bytes along depending on the needs of the network. Like if you can tell the example, like address field, suppose a primary station will be there. This we can assume it, this is the primary station 1, and it will also create the frame like F1. It contains the address like IP6. And if a secondary station creates like secondary station 2 and frame 2 contains the address IP8. So it will hold the from address of one frame. It will contain the two address of a concerned frame. Two address of a concerned frame. So, and this we need to identify under the address field. That means whatever the frames they want to transmit it from by one sender to the another receiver or from one node to the another receiver, that means those frames will need to transmit along with their particular IP addresses, that it will be required or identified by means of a HDLC frame fields. So coming to this, that the third one is nothing but the control field. The control field is one of the field and consisting of one or more than the 2 bytes used for flow and error control mechanism. And coming to that information field, this information field contains the user's data from the network layer or management information. Its length can able to vary from one network to the another network. Like in this OSI reference model, 7 layers will be there. So 1, 2, 3, 4, 5, 6, 7. So 7 layers will be there. Layer 1, layer 2, layer 3, layer 4 and layer 5, layer 6, layer 7. So here the information field contains the user's data. The layer 1 data will be holding by or transmitted to the layer 2, and layer 2 data will be transmitted by means of a layer 3, and layer 3 data we need to check it by means of a layer 4. So layer 4 data is layer 5, layer 5 to layer 6, layer 6 to the last and least link is nothing but the layer is what we can call it as a physical layer. So the information field contains the user's data from the network layer or management information. Its length can vary from one network to the another network layer under the OSI reference model. So coming to that, the last field is nothing but FCS field. The frame check sequence. FCS is the HDLC error detection field. It can contains either a 2 or 4 bytes or 8 bits of data. 8 bits of data we need to identify under the FCS field. The frame check sequences, as I have already explained in my previous class, that CRC, cyclic redundancy check. Cyclic redundancy check means in this whenever redundancy check. That means it is useful to checksum the bits while transmitting those bits from one sender to the another receiver. Meanwhile, if the transmission it would be occurring from one node to the another node, any type of single bit or single node will be corrupted or disrupted or damaged. Those will be identified and replaced by means of the another bits which should be added by what we can call it as appended bits. So to checksum the bits, whether all the bits they will be transmitting in a successive mode from one node to the another node, or any bits they should be corrupted or disrupted, it will be identified by means of a CRC check. That is nothing but the HDLC error detection. This is CRC is also one of the error detecting techniques under the Hamming distances, like Hamming distances, CRC code, cyclic codes, and the acyclic codes and error checksum. These are all the error detecting techniques. Under that one, the frame check sequence FCS is one of the main important HDLC error detection technique. We should be holding or field contains either 2 or 4 bytes and it consisting of 8 bits of data. So here there ends this video, and by the end of this video the students can able to learn the data link layer protocols, like the 4 types of protocols, mainly essentially the connectionless oriented and connection oriented protocols, and the type of HDLC frames, asynchronous and synchronous, like normal transmit mode or normal synchronous mode and asynchronous transmit mode, ABM and NRM modes. And coming to that HDLC fields, the 6 type of fields they need to recognize and need to learn, and I think this video will help them to learn a lot. Thank you one and all.
Like, share and subscribe. Hit the bell icon for more updates.